And please do not turn your cameras on or the microphone. And if you have any questions, please use the chat. But most of all, just enjoy, learn, and have fun here. So who organized this webinar? First of all, the Clinician Engineer Hub, which are aiming to bridge the gap between the medicine and engineering. And this is an international hub, which is a non-profit organization. And what we aim is to actually bring together the clinical and biomedical engineering field and provide talented medical students and clinics exposure to the world of clinical medicine, challenges doctors face in diagnosing and treating patients, and how to potentially solve these issues with cutting-edge engineering solutions. If you want to check our website, please check it. It's very nice, and we have a lot of participants right now. And also the IT Health Alumni Network, which I am also part of, which is a multidisciplinary community of innovators, which are aiming to build the future of healthcare. And our slogan is by alumni for all. And if you want to register for it by being in this conference, you can just scan the QR code. So what our mission is to support the IT health by building an active network of alumni dedicated to activities to improve quality of life, active aging and healthcare across Europe. And our vision for the future is to become the leading European association of health, social and life sciences professionals, entrepreneurs, innovators and executives. And going to our speakers, we have Emre Kazim, who is an AI ethicist based in the Department of Computer Science, University College London. His research interests include algorithmic assessment, the impact of new digital technologies on the structures of state, and informed policymaking. He has a track record of interdisciplinary and knowledge exchange through community and consortia building. And from what I know now, he just finished his PhD a while ago, which is a very good step. And also Adriano S. Koshiyama, who is a researcher in the Department of Computer Sciences, University College London, and his research interests are machine learning, finance, and algorithmic assessments. And he's a specialist in designing trustworthy autonomous systems. So I will now pass the stage to them. Please welcome Adriano and Emre. Thank you very much for joining us today.
Thank you, Liana, for having us. I guess I can share my screen so I can share the presentation. Yeah, I can do that. Perfect. Yes. Let me just share the presentation. Trying to find it. Screen two. Yep. Can you all see my my screen? Yeah.
Yes.
Just is it better now? Excellent. So thank you all for coming. As Liana said, my name is Adriano Koshiyama. I'm a research fellow in the computer science department at UCL. We also have in the call Emre Kazim, which is also a senior research fellow in the computer science department at UCL, and both of us are being supervised by Professor Philip Trulevin, which I will explain a little bit more later. We are in the computer science department. Emre is a philosopher by training, and I'm I would say, machine learning person or computer science or whatever you want to call me by training. We are very interested in the topic of algorithmic auditing. This is a new and promising area of research and practice, which I'll try to highlight the key points, and probably we can discuss later on what does it mean for healthcare, you know, not only on the applied space, but also on the research space. Funny enough, I think we spoke with Liana earlier. We had a 1 hour session today talking about machine learning in health. And one of the things that we discussed, which touched on this one, is about equitability when you're providing a healthcare treatment or prescription. And I'll try to allude to this point later on in this talk. Okay, this is my email. Feel free to reach out. The paper accompanying this talk will be online next week. So if you want to have a copy of it, just drop me an email and I will forward you the PDF. But it's going to be online next week. Okay, I just want to start with a where these things are coming from. We are through an AI and data tsunami, and the key drivers of the tsunami is we're having more and more automated digital marketplaces from everywhere. I can say we can say Amazon, we can say Facebook, we can say which are the key ones, but fintech like Revolut, Monzo, things like Instagram, etc. Everything is becoming now a big digital marketplace, and this combined with a lot of new self-programming algorithms. What do I mean by self-programming? I mean real-time learning algorithms, like machine learning ones mainly, plus huge volumes of data and computing, and there's a change in landscape on ethics and regulation. All this combined is setting up a new research agenda and frontiers and expectations from people. There's a huge dispersion happening at this moment in time. There is still to understand. So I'm showing you on the bottom right the e-commerce penetration in the US. You can see that it took 10 years for the e-commerce to jump from 6% to 16%. So it was growing 1% on average per year. And then during COVID days, in less than 1 year, it jumped 11%. So there are years where decades happens, and there are decades where nothing happens. And that's one of those. In one single year, more things, more transformation has happened than happened the whole decade before. This is just e-commerce penetration, but you can imagine all the other things that have took place. There is huge opportunities now with these integrated service infrastructures, and I guess in the healthcare space, more and more now, big dispersion happening and changing landscape on regulation. And that's what we're going to be talking today, which is the topic of assurance in particular. Just a quick preface. So where are we coming from? This is our history. Good part of this history is part of UCL computer science, in particular Professor Philip, which is the youngest one in the photo. Everything starts from automated fraud detection, which was pioneered by his team 25 years ago, and they built the first inside dealer detection system for London Stock Exchange. And then 10 years later, they built the first algorithmic trading system. 10 years later, they start the idea on law tech and reg tech, which was pretty much last decade, and the digital ethics concept, which started 2016, 17. Not from him, he was already on the space, but he was also one of the UK pioneering on this space, particularly on things like legal service, digital marketplace, computable, executable legal contracts, and things like that. And now we are going a little bit beyond that and talking about auditing and assurance. And there's a huge transformation. I mean, there's a typo here in the presentation. It's not on legal services, but I would say in services in general. This is our history. So our history is pretty much on areas where things were very much regulated. So a lot of things in financial space, legal space, and now more and more crippling across some other areas like retail, healthcare, and so on. We are part of a big ecosystem. We have unique partnerships, in particular with the Center for Data Ethics and Innovation, the Care Quality Commission, the Financial Conduct Authority, and the ICO and the Office for AI and the Longterm Institute. These are key partners. We are now building up some more partners in the construction space, and also on the retail space. This is just giving us the breadth and depth that we need to be discussing this topic. What I'm going to be talking to you today. So this is structure. So the key question is why algorithm auditing, why we'll be discussing this, why you should be watching myself talking about this. I'm going to be quickly highlighting to you the long-term and the near-term challenges that we have in place, and that's why the topic is important, and why algorithm auditing as a way to safeguard society. Second part will be what is exactly algorithm auditing. I'll talk about the key components of it, the risk verticals and auditing levels, mitigation strategies and assurance processes, which are quite important. And now I will end my presentation with the key challenges on algorithm auditing. In particular, what is the adequate types and levels of auditability needed? So why algorithm auditing in the first place? Let's start with the long-term view of what we're talking about. So the long-term view is that we are moving from, let's call it big data, which was the huge discussion that happened last decade. And I remember I was doing my undergrad, master's, and PhD last decade. And that was the catchword. Like there was a moment that everyone was talking about big data, and it was just so sad because most of the people talking about big data, they didn't have a clue about what was big data about. But it caught a lot of people attention and imagination. What was that? And last decade was everything was about data. So data scientists, data protection, GDPR, data, big data. I can keep going. Data protection officer. Everything was data, 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 data. And makes sense. I mean, we were in that exponential phase where the more data we collected, the more problems we could solve. Now we are moving to, at least we believe, we're moving to a new age. And this age will be, let's call it for now, big algo. Maybe they will call it different, but let's call it big algo just as a simple analogy. And we can use the same procedure we used previously to analyze this period. So we can use the 5 V's: volume, velocity, veracity, and variety, and value that we use for big data to understand this time. Very simple. This decade, we will have maybe billions of algorithms over there. The algorithms will be making real-time decision, minimal human intervention. That will be from autonomous vehicles to medical treatment, employment, finance, and so on. Questions about reliability, legality, fairness, accuracy, and so on will be critical characteristics. New services, source of revenue, cost savings, industries will be established from that. The same thing we said about big data, we can forecast the same thing about algorithms. And the previous decade was the sole focus on data protection. Going forward, the focus will be on algorithmic conduct. That's why taking a long-term view is very important. But what about the near term? The near term is this amount of headlines you're seeing and these movements by different regulatory bodies and countries. So companies are increasingly concerned about the algorithms because they are being illegal or unethical, causing major financial loss or reputational damage. And you can look on the headlines on your right, and you see from Financial Times, Thomson Reuters, and Bloomberg, the different companies that got into trouble. And there's many more. There's many. We have probably a database, and there's a website called Algorithm Watch. You can find hundreds of headlines like this. And what is happening is the Bank of England, EU Commission, US, particularly Department of Defense and the other legislatory bodies in the US, other countries like Japan, China, and so on, they're starting to get interested in the idea of regulation, or whatever we may call it for now. In particular, what can we do to avoid making same mistakes we made last time with let's call the names with the case of Cambridge Analytica. where there was that massive data issue, and it not only caused the people were being targeted and used their information without their proper knowledge of how can we avoid that kind of event happening with algorithms. Something bad can happen, and we may be able to control it or not. Who knows? Look at what's happening today with financial markets, and maybe some of you are following up the GameStop saga and things like that. Imagine that algorithms are colluding instead of people colluding or jumping into a bandwagon. Anything can happen, and we don't know. We're unleashing forces that we have no idea what can happen. In that sense, as you can see, the curve is going to go up. The amount of algorithms over time is going to go up. The amount of headlines are going to increase. This is a big opportunity, and the big opportunity is the society is demanding safer, transparent, and fair algorithms. And safe algorithms signal responsibility. And in particular, algorithm auditing is the research and practice of assessing, mitigating, and assuring algorithm safety, legality, and ethics. As with financial audits, and that's what companies been through for a long time, government, businesses, and society will require algorithm audits. And what is this algorithm auditing? So that's our topic for the next slide. So what is algorithm auditing? In a nutshell, you are, as the name say, you are looking at an algorithm from whatever perspective. And in algorithm auditing, there is 4 stages that you should look at an algorithm. You have to look at the development stage, which is the process of developing the algorithmic system. You have to look at the assessment stage, which is the process of evaluating the algorithm behavior and capacities. You have to look at the mitigation stage, where is the process of servicing or improving an algorithm outcome. And the assurance stage, where is the process of declaring that a certain system conforms to predetermined standards, practice, or regulations. And you can see it's a loop. Sometimes you go from development to assessment, mitigation, then you come back to development again, and then you go through several iterations before you can actually maybe go into assurance. But these are the 4 key elements that compose algorithm auditing: development, assessment, mitigation, and assurance. And I will unpack each one of them for you. Starting from development, we need to look at the elements that compose an algorithmic system, which is basically data, model, and processes. Data, as we all know, input, output, simulation environment. Model, objective function, formulation, parameters, hyperparameters, the family of the model, and so on. Processes, what is the design? What is the training of the people involved in it? The documentation, the building processes and the infrastructure in place, open source libraries, etc. We need to look at each one of those components and see what are the risks that may be involved. And when we just look at the model development process, we look at the 5 stages that most of the machine learning people know. We look at the data and task setup, how you collect the data, store the data, extract the data, normalize the data, transform and load the data. You look at feature pre-processing, selecting, enriching, transforming, engineering feature space. After you pre-process your features, you go to model selection, which model should you use, running cross-validation, optimization, and comparison. Post-processing, you add some auxiliary tool, maybe get some feedback, evaluate the impact to the business, and then finally you productionize and deploy. Based on these stages, that's where most of the assessment is performed, as well as the mitigation strategy is put in place. So keep in mind these 5 stages, because that's where most of the focus of interventions and assessment will be laid out. So what is assessment? Assessment is basically looking at 4 key risk verticals. And that's something I want to leave to you as a takeaway. In these 4 key verticals, the reason why we just focus on those is because we have techniques and metrics that allow us to measure and understand them. First one is algorithm privacy, which is different from data protection, data privacy. In algorithm privacy, we look at data minimization principles, as well as adopt privacy enhancing techniques to mitigate personal or critical data leakage. That's quite important. So we want to avoid model inversion. We want to try to avoid your being a target of data poisoning and so on. In bias and discrimination vertical, we try to avoid unfair treatment of individuals or groups, potentially given the protected characteristics. That's what is bias discrimination. On a very broad sense, there is, of course, a lot of mathematics behind it. Interpretability and explainability, the idea is that you provide decisions and suggestions that can be understood by the users and developers, which I think everyone broadly agrees. And performance and robustness, which is the one that most of us have been trained on as machine learning engineers or data scientists, is we want to have a system that performs well and is not vulnerable to tampering or compromise the data that it's trained on. And the reason why we want to do it is to avoid these cases I have on my right. Like Microsoft decides to put a Tinger chatbot on Twitter, and after 24 hours, it has to take down because people just jump in and trolled the the chatbot account. Just basically did some poisoning attacks. That was like straightforward that would have happened, but Microsoft didn't take that into account. Just think about the big the company it is. The second case I'm showing you is the Compass case. Compass is a system that assesses whether an individual has a risk to offend again. So Compass is a system that, let's say, lets you get bail quicker than usual. And you have 2 individuals like James Rivelli and Robert Cannon, and you can see that Robert Cannon has very less, have made less offenses, prior offenses than James Rivelli, but he's considered riskier than James is. And the reason is because the data is unbalanced. Can we do something about it? Yes, we can do something about it. But the problem is when you create a system in the first place, you were just looking at accuracy and you're not looking at anything else. That was a big mistake. So when we look at metrics across these 4 key verticals in relation to the stages, as I mentioned, these are the tools and techniques that you can put in place to assess whether some of these verticals are happening. So if we look at just the case of explainability, in the data and test setup stage, what is important in explainability is the data collection, the documentation for data collection, and the labeling of the data. In the feature pre-processing stage, what is important is having a good dictionary of variables, which everyone forgets to do, but it's quite important to have. In model selection stage, what is important is to keep in mind and have models that are not too complex. In the post-processing and reporting stage, having auxiliary tools that will help you interface and provide information or metrics about the model to individuals. We can talk about some techniques that can do that. And productionized deploying, very important to have a good documentation for your system and interface. When people talk about explainability, you have to ask them which stage are they talking about explainability. Are they talking about explainability to myself, to us, face to face, or they talk about providing transparency to the system, at which stage of the system? These questions are technical questions, and sometimes we debate them on a very high level, and then we don't understand what exactly people mean when they talk about some words. It's like Emre knows better than me, when people say, oh, we need to be more ethical. It's like, which definition of ethics you are talking about? Because there's plenty of them. In the mitigation, which is the third element of auditing, mitigation are basically some procedures that you can be used in conjunction to enhance an algorithm performance or behavior. And there are two main types. One mitigation strategy is on the humans, which basically involves developers being retrained, going through impact assessment, reflecting, maybe just doing something on their agile meetings, things like that, were more, let's say, soft touch. And what we're interested in this case is the mitigation that we can put in place for the algorithm. And it's basically all the methodology that we can improve an algorithm outcome. And you can see it's a loop. People will develop their algorithm, the auditor comes in, assess the algorithm, provides them with some recommendations for mitigation, goes back to the developers maybe put them in place or not, gonna go through another round of assessment. Auditors come in, say, okay, there was an improvement, try these other things. This will be an iterative process that will lead to finally the system being assured or something else. Okay. And of course, going back to the point, there is an interrelation between the different stages and the different risks that someone needs to address and what kind of mitigation strategy they can put in place. So if it's difficult to understand how the data was acquired or designed in the first place, one can decide to do a dictionary of variables and a dataset sheets, for instance. If there's too many variables or too difficult to understand what this person is doing, why they have created so many variables, and now the model is completely unexplainable, a typical mitigation strategy would be to avoid excessive feature engineering, in particular nonlinear transformations of them. In the model selection, would be to use by design interpretable models. Maybe it's not a good idea, but sometimes it might be fine to use just a linear regression or decision tree, which are by design models or interpretable. In case someone is doing some deep learning or doing some more complex modeling, they can use, for instance, line, Shapley values. There are some other procedures that will allow you to build a surrogate explanation for any kind of model you're using. And in the productionizing and deploying stage, just having a recourse interface helps a lot when you are wanting to get not only explanation, but also having people to recourse and judgment you're coming up with. So these are some mitigation strategies that you can put for explainability, and you can do the same for fairness, for privacy, for robustness. I'm just listing a few of them. There is, way more than this. The final outcome is assurance at the end of the day. That's the benefit that companies and everyone involved in it is interested to have at the end of the day. They want to have a report or a web page somewhere where they can say, look, we are doing ethical AI or responsible AI development properly. And it's hard to say exactly without looking at a specific application what is the right way for you to develop assurance. However, one can simply list the different things they can do. One is to look at general and sector-specific assurance. So they can look at national regulation and standards with sector-specific ones, like in finance, healthcare. I mean, in the UK, the healthcare space, from what I understand, is the Care Quality Commissioner and the MHRA are the key ones regulating things. But there's, I think, other ones, and probably the participants can even tell me a little bit more about this space. Another thing is to look at the governance. You can look at technical assessments and impact assessment. That's another way to provide assurance. And no risks. Very important to try to uncover them red teaming, which is basically in a very simple way, you are recruiting a team of experts in a particular field, and they're trying to break into your system. So you're basically almost like recruiting hackers to to jam into your system. But when you do this process, you discover the vulnerabilities of your system is a very good strategy for you to if you want to improve the reliability of what you're doing. Creating monitoring interfaces, typical traffic lights is usually a good strategy. So let's say for robustness, your system is amber. For bias, your system is green. For explainability, your system is red. This is a very simple way for you to communicate with the stakeholders. Certification, we're still a little bit long way for it, but in the US, the National Institute for Standards and Technology, NIST, have already some standards and certification for facial recognition technology systems. So we're probably going to move towards that direction, particularly for autonomous systems going forward. And which I think is going to become a huge market per se, is insurance. And probably the insurance premiums for autonomous vehicles is going to be very different from the vehicles that we have currently at the road in the moment. So what the key challenges are, and then I will drop myself and open for some questions. The key challenges are every time that you go through a auditing process, you usually go through these three key components, okay? And this is before development or procurement stage. The first step is the developers or the business units, they need to provide with a project description. So sometimes you just have a meeting with them and then they tell you about the purpose, the outcome, the team, the technology they're putting in place, etc. This allows you to risk assess. And risk assess means what is the key verticals that this problem needs to be prioritized on? What are the trade-offs that we need to have in mind? Standards, metrics that we may need to take into account when we're doing that. After you've done the risk assessment, and the risk assessment can be the final outcome, could be low risk, medium risk, high risk. Depending on that, you can put in place what is the adequate level of governance. So what you should do in terms of what is the right level for auditability. Should we have white box access? Should we just have a checklist access? Oversight, should it just be oversight by the business unit or needs to have a higher level of oversight, maybe on the organizational level? Accountability, who is responsible for what? Who is developing the system? Who is collecting the data? Who is the human in the loop making the decisions, and so on? And finally, what is the right assurance for that? It's usually performed, as I said, by interviews and checklists with developers and business units. And it may take a few weeks and emails around for this to actually take place, but that usually happens. Just talking briefly about risk assessment prioritization, it's really a case-by-case basis. So I'll give an example when we talk about recruitment. Recruitment, usually the key vertical that we're going to be speaking about is fairness, mainly because there is already regulations in place and legislation in place, very explicit about avoiding discrimination when you are recruiting or make decisions about people employment. In this case, as you can see, the end use of the system is what decides what is important. I mean, in the healthcare space, I would say that probably robustness and performance is the main one, but I can see fairness and potentially explainability being also very important. Privacy, of course, is paramount, but let's say solving privacy by the usual tools, having a good performance of your system, being accurate on your predictions or in your prescriptions is probably the most important paramount, which is all about saving lives. Trade-offs will emerge. As I said, I end up saying in healthcare, robustness is the most important one, but maybe fairness and explainability are as well, a little bit. So you need to make decisions about trade-offs. So sometimes you have to sacrifice the best model in terms of accuracy and move towards a more simpler model. The end user also dictate which right sense to apply, as well as the metrics that you need to use. And that's the first step, which usually informs what is the right level of oversight or what technical audit that you need to put in place. One can identify 7 levels of access that an auditor can have of a system. Don't want to get into much details, but it ranges from white box to checklist stage. The higher the level, the richer and accurate the feedback will be. So if you are at level 7, which is white box level, the feedback that you can provide to the developers of the system is, of course, the best you can. But if for some reason you cannot access the system, you can only do checklists, or you can have just a black box idea of the system, the feedback is going to be less accurate, less detailed. But sometimes that's the kind of the sacrifice, because you don't want to be peeking too much in someone's systems because of IP restrictions that may end up being disclosed. That's a trade-off that you're going to have to bear in mind when you're doing that. And as well, every level, 1 to 7, as I mentioned, will have its own interrelation in terms of with the verticals, the type of information considered, the feedback detail, the typical application, and the appropriate oversight. This is just like a generic view. Way more information, details can be put in place about this table. Just give you a quick, simple example. If you're developing a sales forecast system, very simple system to be developed these days, usually these systems are not that risky in the sense that you're coming up with a sales forecasting. Maybe people are going to put money behind it, but generally speaking, this system is not making a life and death decision. There will be someone else being formed by the system, and then they will make a final decision. So there's a human in the loop. So usually this kind of system, they have very low risk in themselves. So we probably can be happy with just level 1 access. If you're developing a self-driving vehicle, that's a bit more complicated, because if you're going to be having these systems on the streets, it might be the best way to do it is providing full white box transparency for the auditors, so they can have a look at it and try to break the system before the system breaks everyone on the street. Okay, different levels will impact on the governance of the system, and above all, this is application driven, and then we can have a chat as well about it. Jumping to conclusions and finishing my talk. The key elements to this is it's a promising area of research and practice, very much in its inception phase. Very keen to see how this can be intertwined in the healthcare area. Do drop us an email if you're interested in this space. At the moment, there's many research institutions. I mean, I can list to you literally from Oxford, Cambridge, EUS, elsewhere. There is opening institutes on ethical AI and whatnot these days. And many organizations are now on this ethical AI bandwagon. And it's just going to keep growing. And definitely will become a trade barrier for sure. So big commercial implications. We expect that the 20s the emphasis will be on our conduct, like the data protections for the 10s. And unfortunately, many headlines will pop up as well. That's it. That's our contact. Feel free to reach out. Thank you, Liana, for the opportunity. Thank you.
Thank you very much, Adriano. Are there any questions from the participants? You can also unmute yourselves and ask the question. Okay, we have a question. How do you see this playing out in the future with more and more projects using AI as a service, basically reducing your chances to audit to level 1?
Yeah, I think the one thing that is happening, and we're doing a project at the moment, is with big corporation, and they are procuring an AI software from a company that that helps with recruitment. So they basically look at people CV and provide a score out of that. So we can call it maybe potentially. No, it's not as a service. Maybe he means like more H2O AI potentially, but let's say it's one of these ones that they actually procure the firm. What happens in this case is if it's considered a high risk, the company will require that the provider go through an auditor before they actually can provide the services. So it might be that just a checklist works. So if you're developing just, if you're going procurement and you're developing just a sales forecasting, that's fine. There will be no need to have an auditing in place. Like, nobody cares. But for this kind of systems, the auditor will need to show up. And the big thing is if, and it's becoming part of the governance, if the risk is too high, and if the company doesn't collaborate or doesn't help, then they are just basically taken out of the procurement. If he means by AI as a service as like H2O AI, then H2O AI is just basically a platform where, as you said, you do auto ML, but that doesn't exclude the fact that you are developing a system for X, Y, and Z, and then you may have to go through procurement. What's going to change is the mitigation strategy that you have to put in place for this kind of companies. Companies using Watson or Azure AI service for HR, yeah, that's the case. So if a company is using Watson for HR, in particular HR, let's say, and there is already regulations and things in place for what kind of metrics they need to report and things they need to be looking at the moment. And in particular in the US, not much in Europe, funny enough, in this case. But it's also crippling over Europe. And yeah, they need to, they will have to go through an audit in this kind of applications. Some other applications probably no, the remaining knowledge.
Okay, good questions. Are there any more questions? Don't think so. Any final comments from you, Adriano, and you, Emre?
I think Emre wants to say something.
No, just saying, yeah, there's a lot of, just the one interesting thing I think about this is that it's, as Adriano went through in the presentation, it's looking at the performance of the algorithm in the context of broader issues of governance. So it's not just, let's say it's a kind of an engineering literate way of looking at the performance of an algorithm rather than just putting in some abstract principles or other kind of governance structures that are not probing the actual performance of the system itself.
Okay. So I think we don't have any.
Yeah, can I just ask a question to the audience? Maybe someone wants to answer that. I mean, we're not much immersed in the healthcare space. And the question to you all is, have you been listening to any noise about this area? Like people coming and saying ethical AI, or someone coming and say explainable AI, or something like that? Is it coming through?
From my side, I can say that I never heard of it but I'm not directly linked to the hospitals and everything.
Interesting.
Maybe our participants would like to unmute themselves and say something about it. Wolfgang, that asked the question as well. Maybe you have something to say. People are too shy.
I don't work in the health space, so I can't say much about that. I worked in regulated tech, and I actually, for a while, I was in a gremium with the Bank of England to talk about AI ethics.
Nice.
A couple of years ago. That was when it just started that people were talking about this here in Europe. So.
Compliance conference for big pharma mindset. Yeah. Yeah, let's see. I think it may actually become something, or maybe it's another hype that comes and goes. Right?
Yeah. Well, the interesting thing about compliance is, let's say with respect to national standards or regulation, is that it gives us a target to audit according to. It gives us a kind of way in which to objectively say that a system is performing lawfully. So another way in which to audit, to have a target standard, if you will, is that in particular industries, I'm sure big pharma is one, there must be some really quite robust and detailed, if you will, standards by which a product has to be assured to. So sectors have their own standards, and we anticipate that medicine is going to be pretty robust. Okay.
Questions, comments?
Yeah. Again, I'm just going to write up my email here in the chat now. Feel free to reach out. We're gonna, as I said, we're gonna upload the paper to archive, SSRN, a lot. On next week, I'm gonna get more feedback now. Apparently, got an email now, so there's more feedback coming. So we're preparing something over the weekend, and then next week it's gonna be widely available. But if you wanna have the current copy, just send me an email, and I can forward to you.
Thank you very much.
Okay.
Thank you very much for joining us today and for accepting being our guests. And thanks to all the participants for being here.
Yeah.
So I wish you all a good day and stay safe and healthy.
Yeah. Thanks, Lena, for the opportunity.
Thank you all. Take care.
Bye.